You said sine x?
Sine x plus x squared equals 1. Newton's method, 6 decimals.
Very good. So first we have to create the function, which would be sine x plus x squared minus 1, right? Because I have to rewrite it like this, then I will have to say, number one, continuous, function continuous, and I'll have to find an interval as a sum or difference of continuous functions. In number two, I have to find f of something that is greater and f of that something that is less than.
As a, what's that say?
As a sum or difference. It's a sum or difference of continuous functions. Sine x plus x squared minus x. Sum and difference. And then I have to go to the graphing calculator and put in this function that I just created, sine x plus x squared and minus 1. And I'll go to second and table, but first I have to do this all the time. Second and table. And I will put in some numbers because I need an interval that is 1 unit length, not between 0 and 10, right? So 1 unit length, and try to find, I see the graph here. So I see that there is x equals 0. I'm going to try it right here. 1, 2, 3, 4, 5, 6, between 6 and 7. So let me check the mode also. Yeah, okay. So let's say between 6 and 7, because I don't want this. I don't want a solution. So 6 and 7.
So it'd be f of 6 and f of 7.
Oh, it just it went to something else. I thought that was okay. Let me check that I put everything correctly. Okay. So I'm gonna put in 0, 1. That's all I need. It was graphing something else in that cheat sheet that I have here. So f of 0 is a negative number, and f of 1 is a positive number, so I go between 0 and 1. It was a totally different, I don't know what it was showing me. Okay, so
It's not greater than or equal to?
we are only trying to see whether it changes sign. We're not interested in equal to 0. I hope it's not equal to 0, because if it is equal to 0, then I found the solution already.
Oh, yeah.
So then I'll say number 3, from 1 and 2, by the intermediate value theorem, there exists a C between 0 and 1, such that f of C is 0. So there is a solution. So from 1 and 2, and by the intermediate value theorem, there exists a solution, there exists C in the interval 0, 1, such that f of C is 0. The intermediate value theorem doesn't give us the solution, but it tells us that there is a solution there. And now I have to create Newton's method, and I'm going to create a function that is like this. So the function at the top, sine x plus x squared minus 1, and its derivative at the bottom, cosine x plus 2x. This is the function that I need to put in the graphing calculator, which is x minus f of x over f prime. Is that okay? Okay, so now let's put it in. So in y equals, don't delete what you have, just insert the x, and then minus, put parentheses around the top, and divide by parentheses. The denominator is cosine x, close the parenthesis, and plus 2x. And now I have to decide where to start. You can start with 0 as long as what? F prime in the denominator is not 0. Well, cosine 0 is 1, so the denominator is not 0. I can start at 0. I can definitely start at 1. So where do you want to start? So we get out of that, and we go to variables, and we pick the first function, y1.
What's the button you hit to make it so it asks you? Is it mode?
Second and table set. This one.
Like I downloaded the TI-84 on my calculator, but it won't let you ask. Like it doesn't even go to negative numbers. It goes to 0, and then like maybe 10.
It should allow you to change.
Oh, it's an app.
Okay.
On the phone, it's not a real calculator.
So you go to a second and table set, and then you change the independent. Yeah. Only the independent, not the dependent.
Yeah, when I pull it up on my app, it just says table start and then triangle table.
And then we go to variables, and then function, and then you choose function y1. You want me to show that again?
Yes, please.
So variables, y variables,
oh, yeah, I know,
and function, and I choose function y1 because that's where I have Newton's method, and I plug in 0 if we decide to start with 0. Do we decide?
Yeah, that's fine.
Okay, so then I get whatever this is, and then I get second and previous entry, and I overwrite the 0 with the previous answer. No, I will not put in 1. I will overwrite it with the previous answer, press enter, because then I want to do this all the time. Previous entry. So you said 6 decimals, right? So I will write this as x1. I will write down this as x2, x3, x4. I'm not there yet, right? So again, 1, 2, 3, 4, 5, 6. I'm done. So x1, x2, x3, it converged in 4 steps. So, and we have to write this down. So x1 is 1, yes?
Did you write x0 as being 0?
Yes. Okay. X sub 0, which we chose to be 0, yes. Thank you. And I will copy 7 decimals till I get to x4. So then the next one is 0.6370680, and the last one that I need is 0.636732. You can put 6 if you want, but there's no need.
With part 2,
yes.
Is that sufficient just to say 1 is greater than on the bus stand? I think normally, whatever it is, like
it's up to you. I wouldn't bother because I don't need these numbers.
Yeah.
You already checked. You know that f of 0 is a negative number. You already checked that f of 1 is a positive number. I don't need these numbers.
Okay.
We're not going to use them anyway.
Yep.
So it's good enough that you presented the intermediate value theorem. Yes.
I can't see.
Of course. It's not clear.
Yeah.
It's blurry.
Half of freeze there, and then the other part of freeze on the other page.
Oh, you wanted the previous page.
Yes.
Oh, I'm sorry.
Yeah, that was the problem.
So you show that you know that the intermediate value theorem is applicable only to continuous functions, and only when, in this case, you can guarantee. Say it again. From 1 and 2 by the from 1 and 2 by the intermediate value theorem, there exists a number c in the interval 0, 1 such that f of c is 0. Wendy?
My gosh, Jordan, it's not working.
Okay, let's do it together.
I got pretty good at them. I made one little itty bitty mistake.
That's all you need.
Rose the whole thing.
So is this 1, 1, 1, 1, 1, 2, 2, 3, negative 1, and 11, 14, 5, correct? Yeah. Okay. Good, so I have this already. I'm using row 1 to add it to row 2 with negative 1, correct?
Yep.
And row 1 again with negative 2 to add it to row 3, correct? Okay. So then I copy 1, 1, 2, and 11. And then I have negative 1 times 1 plus 1 is 0. Negative 1 plus 1 is 0. 2 times negative 1, negative 2 plus 3 is 1. Now this is negative 11 plus 14 is 3. Do we get 0, 0, 1, 3?
Yep.
Okay, then the next one is 0. And here is 1. And here's negative 3. And here's negative 6.
Yep.
Okay, so now this is done, and I cannot do anything with the first row or swap, but I will swap these two.
I was swapping the wrong rows.
You cannot swap the first row, because if you swap the first row, you destroy the 1, 0, 0. You cannot do that. So once you're done with the first column, you can no longer swap the first row with anything. We can swap the other two. You understand that once I swap these two, I damage the first column and I will never solve.
I was wondering about that.
So now I will say that row 2 becomes row 3 and row 3 becomes row 2. And then I copy 1, 1, 2, 11, and then 0, 1, negative 3, negative 6, and 0, 0, 1, 3. Is this okay? So now the first column is done. The middle of 1, this is done. The only concern I have is just this. So I have to multiply row 2 by negative 1 and add it to row 1. So I copy the second row, and of course the third one because it happens to be so. So 1 times negative 1 plus 1 is 0. Negative 3 times negative 1 is 3 plus 2 is 5. And negative 6 times negative 1 is 6 plus 11 is 17. So now these two are done, and I cannot swap anything anymore. I also have this. So I know that I have to multiply row 3 by something to add it to row 1, and row 3 by something to add it to row 2. And what will I multiply to eliminate 5?
-5.
Correct. And to eliminate negative 3?
3.
Good. So this is the final step. One times negative 5 plus 5. 3 times negative 5, negative 15 plus 17. 1 times 3 minus 5, minus 3. 3 times 3, 9, minus 3. So it appears that is 2, 3, 3. We have to go back and check. Would you mind checking that to see if it's correct?
Oh, definitely.
And I will continue with Paul and Justin. Okay. Ready?
Oh, no, it's not yet. I'm still, yeah, my question is.
Ready?
For what values of constants A and B is
Yes.
1 to 3, like parentheses 1 comma 3, a point at the inflection of the curve, y equals ax to the third plus bx squared.
Okay, so we are asked to find A and B such that 1 comma 3 is a point of inflection. Correct. Very good. Perfect. So first of all, 1 comma 3, to be a point of inflection, 1 comma 3 has to verify this equation because it's a point on the graph. And this is the expression or the function, right? So when x is 1, y is 3. So I have a plus b equals 3. This is my first equation carved in stone. I have two variables. I have to have two equations. So 1 comma 3 is a point on the graph. It's an inflection point of this graph. So 1 comma 3 has to verify the equation. So far, so good? Okay. Now, because we're talking about point of inflection, I have to get to eventually to which derivative?
The second derivative?
Correct. So then y prime will be 3ax squared plus 2bx. Very good. And then the second derivative will be 6ax plus 2b. Very good. So if for this to be an inflection point, y double prime when x is 1 must be
0.
exactly. We're talking about a polynomial function, yes.
I didn't follow that.
So how do I find the point of inflection of a function? I find the second derivative and set it equal to 0.
Right.
I am told that 1 comma 3 is an inflection point,
Okay.
which means when x is 1, the second derivative must be 0. Because that is the inflection point at x equals 1.
are you solving the second derivative for 0?
I can't. I have a and b.
Yeah, right.
So I am told 1, 3 is the point of inflection, which means the
6a.
second derivative at 1 must be 0.
Must be 0, right?
Correct.
So 6a plus 2b equals 0.
Exactly. So 6a plus 2b equals 0, and this is what I'm going to add, and I'm going to divide both sides by 2. So 3a plus b equals 0, and this is my second equation. And I divided by 2.
Okay, I didn't do that.
Yeah, I divided by 2. Now I have a question for Wendy. I want Wendy to tell us how to solve this system. I want you to tell me how to solve this system. You have 2 methods. Choose one. So it's a plus b equals 3 and 3a plus b equals 0. How will you solve it?
3 plus b equals 0.
Yes, a plus b equals 3 and 3a plus b equals 0. Well, how will you do it?
How would you do that?
She knows. How many methods we have for systems like this? Sub
Oh, substitution.
or
Addition.
exactly. Choose one.
Oh. Addition.
Okay. What would you eliminate?
I would multiply the top line by negative 3.
Awesome. So negative 3a, negative 3b equals negative 9. 3a plus b equals 0. What now?
Then you get rid of the 3a's. Then you have negative 3.
See, I told you she does. She just wants to give me a heart attack every chance she gets. Okay, so then we go back, right? We go back with b to determine a. Correct? Good. So then a plus 9 over 2 equals 3. It's up to you if you want to eliminate fractions first or just move 9 to the other side. So a equals 3 minus 9 halves. 6 minus 3, right? A equals negative 3 halves. So the ordered pair is negative 3 halves, 9 halves. See, she knows calculus.
Okay, that's not the one I got wrong.
But is it clear?
Yeah, oh yeah, yeah. I mean, like, I did it, so there were 2 problems, and one of them I got wrong, and that wasn't the one, so I got another problem.
Yes.
Was that? It was one of the bonus tests.
Oh, okay.
Can I do a short problem with Wendy and then I'll come back?
Oh, no, continue with them for a second.
Okay. She gave us permission. Let's continue.
I don't know the whole, but it's number 32 on page 352.
32 on 352.
Yep.
Three 350, 44, 52, 60.
I just need to. I do have a question.
Yes. 32 on 352.
It's a simple question, but I don't know why, but for some reason, whenever I see e to a number x, it throws me off. Whatever the difference is.
So with this one, we want to graph it, the whole spiel. Is that the one?
Yeah.
32 and 352. Is that the one you meant, Justin?
That's the one I said, but maybe that's why I got only half points because it's not the problem.
Okay, so which one are we looking at?
This one says it is a graph, but it's y equals x minus 2, 3x, or e to the negative x.
So
we
you
can do this one, that's
want
fine. This is fine.
Yeah,
It's the same thing, I think.
so what was that? Y equals x minus 2?
Yeah, times e to the negative x.
Okay, so I see two
Well, I mean,
functions. It doesn't matter to me, whichever you want to
We'll
graph.
do the second one because he was talking about like e to a number kind of throws him off.
But these are both the same thing, e to an
Well,
x.
he said when there's a number in front of x, so let's do that one. Let's do the.
No, I don't think that's what Paul meant.
Isn't that what you meant?
Yeah, I mean, the first one is kind of what I'm looking at.
Okay, but what?
Minus x squared.
That's fine.
Yeah, but that's
We're,
an e to a function. But I guess when I see like e to 5x or e to whatever, like if I'm doing derivative, what is the derivative? Is it just e to 5x over and over, or
so
Times
e
five.
to the x prime is e to the x
yeah?
times x prime. E to a function of x prime is e to the function times the function prime.
Wait,
Do like e to 4x.
So e to 5x, 5x is u of x.
yeah.
It's no longer x. So I have e to 5x times 5x prime, which is 5.
Okay.
So e to 5x is e to 5x times 5.
Okay.
It cannot be the same, right?
Yeah, I mean. I
Yeah,
don't know
e to
why,
the
but-
x and e to 5x cannot be the same.
Yeah, I don't know why, but
Okay,
it just throws me off for some reason.
okay. So what are we doing then?
Can we do the first one?
Yeah, first one, very good. So y equals e to 2x minus x squared. I did pull solutions for this, didn't I?
Well, this isn't the problem I did, so this isn't the problem.
Okay, that's fine. That's fine. Okay, so first of all, we have to find the domain of this function. The exponential function is defined everywhere. This is quadratic. There are no restrictions whatsoever. So then I can get my table started. So f prime of x, f of x, and f double prime. Domain all real numbers. So now I focus on the function first, meaning I find the limits at infinity and the x and y intercepts. When I'm done, I move on to the first derivative. When I'm done with that, and so on and so forth. So I will definitely plug in 0, and I get e to 1. E to 0, which is 1, I meant to say. So when x is 0, y is 1. Now, there is no point in writing y equals 0 because e to 2x minus x squared will never be 0. We know the graph of e to the x. It will never touch 0, right? Even if this is a negative number, so if the power is positive, it will look like this. If the power is negative, it will look like this. It will never touch the x-axis. If it had an x in front, yeah, I could have said x equals 0. But e to a power is never 0, ever.
Right.
The limit may be, but there is no x-intercept. Okay, so this is the y-intercept. There is no x-intercept. Now I have to find the two limits. Limit as x approaches infinity from e to 2x minus x squared, and limit as x approaches negative infinity from e to 2x minus x squared, because I have to put something here and here. Okay, now, when x approaches infinity, where does the power go? Careful. Exactly. So now e to negative infinity, I shouldn't write this, this is not legitimate, is 1 over e to infinity. Where does this go?
0. Which one is that? The first one?
Okay, now let's look at the other one. So let's go back. E to 2x minus x squared.
Well, it's negative, so it's still go to negative infinity.
Correct. So e to negative infinity is?
0.
Okay. Because this is more powerful than this. This can be disregarded at infinity. This number, this quantity will always cover this. Okay, perfect. So there is nothing else I can learn about the function from the function itself. So now I move on to the first derivative. So it's e to 2x minus x squared times 2 minus 2x. Or better for now, negative x plus x minus 1 e to 2x minus x squared. I factor out negative 2. So now I know that y prime
So you
So
don't
this-
need the negative 2 or you don't need the 2 anymore once you factor it out.
Of course I need it. It's my brain. I'm sorry.
Okay.
My apologies. No, I can't get rid of stuff like that. I can get rid of stuff like that with negative 2 or 2 in an equation, not in an expression or a function. I just didn't write it. I'm sorry. My apologies. So critical numbers come from y prime being 0, not from undefined, because this is never undefined.
So 1.
So x equals 1. So I have 1 and I have 0. I have to determine this value here. I need the y coordinate of this point. So 2 minus,
So e to 1.
so e to 1. So I'm going to say 2.7 because I'm,
Okay. You said
this cannot be 0, this cannot be 0. The only one is x equals 1.
what do you mean? I'm saying
When I said this expression equal to 0, this cannot be 0, this cannot be 0. X minus 1 being 0 means x equals 1.
oh, I see.
Ignore the
You have
2
to ignore
and
the-
2 minus 7.
Yeah.
Okay, so that's 2.7. Okay, now I have to study the sign. So let's plug in 0. When I plug in 0 on this side, this is a positive number, and this is a positive number. When I plug in 10, this will be negative, and this will be positive. And now we look at the first row and the second row to make sure that they work well together. From 0 to 1, correct?
Increasing.
Good. From 1 to 2.7,
Increasing.
from 2.7 to 0. Good. So now I have to find the second derivative. Ready? So,
It's just the same derivative.
no, of course not. It's a product. So let me copy y prime, negative 2, x minus 1 times e to 2x minus x squared. I wish, right? So the second derivative, leave negative 2 alone, outside, waiting. The first function prime is 1. E to 2x minus x squared plus x minus 1 times e to 2x minus x squared times 2 minus 2x.
Oh, okay.
I will factor out e to 2x minus x squared. And I have 1. And then I have plus. I distribute. 2x minus 2 minus 2x squared and plus 2x. So one more time.
So,
I have the 1. Yes.
can you just, like, as you go, like, where it says y double prime,
Yes.
can you just, like, kind of point to each thing?
So negative 2 stays
Yeah.
in front. The first function prime is 1 times the second function plus
Yep.
the first function times the second function prime.
Yep, okay.
So then I factor out e to 2x minus x squared, and I have 1. And I distribute 2 to x minus 1, I get these 2. And negative 2x to these 2, and I get negative 2x squared plus 2x. So now I have negative 2 e to 2x minus x squared. And let's see what we have. Negative 2x squared plus 4x and minus 1. I will factor out negative 1. That will take care of this negative 1. So then I have 2x squared minus 4x plus 1. So the second derivative will be 0 only if 2x squared minus 4x plus 1 is ever 0. And I need the quadratic formula. And Wendy will tell us how to solve this.
Oh.
B. It starts with B.
Yeah,
Negative
it's
b.
It's negative
He's-
b squared.
Negative b
Which is 4.
plus or minus,
and then,
negative b plus or minus the square root of
4.
squared
So it'd be 16.
minus 4 times 2 times 1 over 2a. So it's negative b plus or minus the square of b squared minus 4ac over 2a. So then I'll put it in the graphing calculator. In parentheses for the top, 4 plus the square root, in parentheses, 16 squared. No. Why did I write 16
Just
squared?
Because 4 squared.
4 squared is 16.
Right, but I put
you
squared
put
by
squared.
mistake. So negative b plus or minus b squared minus 4ac. So the square root of 8. I need an approximation anyway. I have no choice. Okay, and then divide by 4. Okay, so this is 1.71, and the other one with a negative. So one solution is 1.71, and the other 1.3. So 1.71 and then 0.3. Of course, they had to be condensed in one part to make my chart go berserk. Okay. So this is always positive. In between solutions, this will be negative, and outside positive. How do you determine this? Just let's plug in 0. When I plug in 0 is positive. Let's plug in 10. When I plug in 10 is positive. When I plug in 1, 2 minus 4 plus 1 is negative. So opening upward, downward, upward. So this is a local max, and I have to determine this value, and I have to determine this value for inflection points. So I have to plug in 0.3 in this function. So
How do we know if it's an inflection point again?
the second derivative changes sign, and it's 0. Second derivative changes sign. So E, is that okay? So 2x minus x squared. And I want to plug in 0.3. And I want to plug in 1.71, approximately. So I get 1.66 and 1.64. 1.66, 1.64. Okay, so now we're ready to graph the whole thing. Ready? Yes?
Let's need that other page. When you finish the second one. Yeah, that.
So say again what an inflection point actually is.
Inflection point is when the second derivative is 0 and it changes sign, or it's undefined where the function is defined and it changes sign. It changes concavity. So 0.3, 1.66 will be an inflection point because the second derivative changes sign. Okay? So now we graph. Y equals 0 horizontal asymptote. Y equals 0 horizontal asymptote. Is that correct, Wendy? When x goes to negative infinity and the function approaches 0, is that y equals 0 horizontal asymptote? Same here? Good. So let's graph. So I have y equals 0 is the horizontal asymptote. At 0 is 1. So this is 1, 2. So at 0.3 is 1.66, and that's 2, and that's 3. At 0.3, 1.66. And at 1 is 2.7. What did I do? Oh, no, I have to delete that. It's here. So at 1 is 2.7. And at 1.71, and at 1.71 is 1.64. 1.71, again 1.64. Okay, ready? to look at this? So coming from approaching the asymptote, increasing, opening up. It continues to increase. So this is the y-intercept. It continues to increase to this point where it changes concavity. It starts opening down, still increasing to this point. Still opening down, starts decreasing to 1.7 to this, where it has another inflection point, and it changes concavity, opening upward, approaching 0. This is the graph of e to 2x minus x squared. So this is an inflection point, and a local max, and it happens to be an absolute max. So local max and also absolute. Inflection point, changing concavity. And here the y-intercept. Any questions? Yes. Yes. Wendy's turn. She's been waiting patiently.
Oh, I had to get that